Welcome to Chapter 4. Here is Lesson 4-1 on congruent figures. First, we start off with a theorem about triangles. So here we go. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Here's what we mean. They're showing you that in this first triangle, A has one arc mark, so that matches up with the one over here on D. Also, B has two markings for its angle, which corresponds to angle E on the second triangle. So the result here from this theorem is that C has to be congruent to F. So here we go, C congruent to F. So, by the way, if you want to pause the video right now and go get your cards, then you can add Theorem 4-1 to your stack of note cards. Also, let's have another note card for this. Congruent polygons, here's the definition, are polygons that have corresponding sides congruent and corresponding angles that are congruent. So these hatch marks, one here matches up with the one over here, two of them on this side match up to these two over here, and finally three hatch marks match up with three hatch marks. So when we're talking about side lengths being equal, we'll use hatch marks through them so that we can figure out which matches up with which. And then when we're showing congruent angles, we'll use these arc notations. So E, with its one arc, would match up with angle H. So these two polygons are congruent because we're showing you with hatch marks that their corresponding sides are congruent and the corresponding angles are congruent. So now here's the statement that we can make. Triangle DEF is congruent to triangle. It's not IHG. Here's the big deal with this. You must put the corresponding letters in the same order when you go over to your other triangle or your other polygon name. So if I started with D on this triangle, I have to start with G when I name the other one. And if E is my second letter naming this triangle, I have to use H because E and H match up. And so that means F, which is the last one here, needs I to be the last one in this name. So if you said DEF, the only correct answer for this side is GHI. But what if you used, instead of DEF, you called this triangle EFD? Well, then you would have to find out which of these angles matches up to the ones over here and use that letter first. So what is it going to be? H would be the first letter when you name this other triangle. So EFD would be congruent to HIG. Do you see how I'm working that? So make sure that your letters match up when you name these things. So then, let's do some examples. Name congruent parts. A, B, C is congruent to Q, T, J. That means that everything about A will match up with everything about Q. Everything about B matches up to everything about T, and C matches up with the J. So, here we go. Here are the angles. Angle A congruent to angle Q, and I saw that because of the way they named it. So A goes with Q, and here's how I'm going to note that. One arc here, one arc here. Angle B, well, let's see, B was second, so I go over here and I look at T. So T was the second letter. So now I'm going to make 2 arc marks. And the last one was C goes with J. So I got to fill in the C here, and I can put 3 arc marks on that. 1, 2, 3. Please use these annotations in your book. And now how about the sides? Side AB matches up with QT. Okay, so I've highlighted them. I should have probably used the hatch marks like I said we were going to. So I'll put 1 there and 1 there. Then what about TJ? Well, here's T to J. That would match up with side B to C. So I can put 2 hatch marks on that one. B to C is the segment that I need in there, and you have to have the line over the top. And lastly, from A to C matches up with Q to J. So I need 3 hatch marks on that. 1, 2, 3. So A to C is the same as Q to J. Now, here's a question. If I had said A to C is congruent to JQ, is that correct? No, it is not, because I have to name this stuff that's congruent in the same order on the other figure. So if I start with A and then put C, I have to start with the corresponding thing, which would be Q, and then put the J. Ask me if that's unclear at all. Then example number 2, using congruency. So say we have a triangle XYZ is congruent to another triangle KLM, and they tell you a little bit more. This angle Y would be 67 degrees, and angle M is 48 degrees. So now we have to find the measure of angle X. Well, you know what? There's nothing like a good diagram to help us get through one of these situations. So let's try this. Let's draw triangle XYZ. So here's X, Y, Z. X, Y, Z. And they give me some information here. Angle Y was 67 degrees. Got it? Okay, now there's another triangle, KLM, and they gave me something about that. Well, let me draw KLM. I'll start here and go KLM. And they told me that M is 48 degrees. Got it. Okay, so they also told me that these two are congruent. So what can I fill in on the other triangle? Well, angle Y corresponds to this angle, the second angle in this name, so that would be measure of angle L. And if Y is 67, that means L has to be 67. And then angle M, they told us, is 48 degrees, and that matches up with, here's M, it's the third angle mentioned, so that matches up with the third angle mentioned over here, so that's angle Z. And we knew that that's 48 degrees, so this has to be 48 degrees. Hey, look, you know 2 of the angles in a triangle. What do all 3 angles add up to? That's where we have to go with this question, because we're trying to find angle X. And we know that all 3 add up to 180. So if we start with 180 and we take away the 67 and the 48, we find the measure of angle X, which happens to be 65. There it is, 65. Now, I did all that in a diagram. Now let's watch and see how we figure it out in sort of this step-by-step 2-column proof view. First, we know that all of these angles, X and Y and Z, add up to 180 because that's the definition for triangle sum theorem. And we know something about angle Z, that it's 48, because they told us that M was 48. So we can fill that in. The corresponding angles of congruent triangles are congruent, which came from this. 2 angles, then the third angle has to be congruent. And right here, congruent polygons, or in this case, congruent triangles, have corresponding angles that are congruent. So measure of angle Z. Ooh, I got ahead of myself, I'm sorry. Do you mind erasing in your book? Sorry. So measure of angle Z would be congruent to measure of angle M, and then substituting the 48. There we go. Now we can substitute. We know something about angle Y. They told us that. That's 67. And then angle Z gets substituted right here with its 48. So x plus 67 plus 48 equals 180. Simplify that. 67 plus 48 is 115, and then subtracting 115 from both sides leaves us with 65. So here is the logic that we used in the diagram. So example 3, we have to decide if ABC is congruent to CDE. Now you look at the diagram here and you're probably saying, hey, yeah, that's kind of congruent. Well, here's why the order is important when we write these letters. So let's do this. From A to B has to be congruent to C to D. Well, let me highlight those. A to B, so that side, congruent to C to D. Now, this is 3 and this is 4. Uh-oh, doesn't look good. But you know what? Let me just go through and highlight the rest of these in the order that they're given. From B to C, should be congruent to DE. Well, that's D going up to E. And then lastly, from C, oh, there we go, C over to A would be E to C. C to A, E to C. Well, those look congruent because they have the little hatch marks, but this green and blue line matching up with this green and blue line, that doesn't really work. So let's follow this logic here. If these two triangles are congruent, then this angle, BAC, which is this vertex here, has to be equal to, don't look at the diagram, look at the order of the letters. So they said from B to A to C, which is up here, B to A to C. So I have to look at these letters. I start with the middle letter, go to the first letter, then to the last letter. So I'm starting at D, going toward C, and then over to E. So that's actually this angle compared to this angle. So BAC congruent to DCE. Angle DCE. But the diagram shows that BAC is noted here. Let me clean this up a little bit. It's noted as being congruent to E. So DEC, not DCE. DEC is what the diagram shows. Our lettering has it out of order. So this statement is not true. But if we change the order that we're writing this statement in, then we do have a true statement. So that's why this order is important on how we name these triangles. So let's look again at the diagram and see that BC is congruent to another side. Look, here's 4, here's 4. So that's actually congruent to DC. And we have BA congruent to DE. And notice that if I'm starting with B, I see that's the right angle, so I start over here on the corner that has the right angle. Lastly, from A to C would match up with E to C. Sorry, I needed segment lines over those. So also they show you in the diagram that angle CBA, so this right triangle, would also be congruent to CDE for that right triangle. Angle CDE. And that BAC was congruent to DEC. So, using theorem 4-1, which says, if two angles of one triangle, got it, are congruent to two angles of another triangle, then the third angles are congruent. So that tells me that ECD has to be congruent to ACB. And you know what else? You knew that those angles were congruent because why? They're vertical angles. You didn't even need to use the theorem to prove that. So, the correct way to list these two triangles being congruent would be a triangle ABC is congruent to triangle EDC, not CDE. So let's check. Do we have this figured out? List the congruent corresponding parts. So let's start with this. If I write WY would have to be congruent to what? You have to fill that in and show me your answers when you complete this. But I'm going to give you the first one. So WY is congruent to what? Segment WS is congruent to what? And segment YS is congruent to which other segment? So I've picked the three sides that make up WYS. You have to give me the correct order and sides from this other triangle, which has the vertices M, K, and V. So how about the angles? I'm actually just going to go with a simple version of the naming. I'm going to give you angle W, congruent to angle M. So the first letter here, first letter there. Angle Y, second letter corresponds to the second letter, so that's Y equal congruent to K. Third letter S, congruent to third letter V. So angle S congruent to angle V.